This segment of our course deals with 3 types of flexible couplings, including how they work and the nomenclature of their parts. The 3 types we're talking about are the gear, grid, and disc couplings. First, let's look at the gear coupling. There are actually only a few basic parts that make up this coupling. These are the coupling hubs that are mounted on the shafts. As you can see, there are gear teeth around the inside of each of the hubs. These teeth mesh with the internal teeth on the inside of each bell. The bells are then bolted together with these bolts. Since the gear-type coupling must be lubricated, there is a grease plug here, and grease seals between the hubs and the bells. That's basically all there is to this type of flexible coupling. This hub is mounted on the drive shaft. The hub then turns this bell through the meshing of the teeth we showed you a few moments ago. Since this bell is bolted to the other bell here, both bells turn during the operation. The teeth inside the second bell then turn the hub inside it and the driven shaft mounted in the hub. Remember, the gear coupling will compensate for some misalignment and for some axial movement of the shafts. However, the gear-type coupling will not absorb shock loads, such as power surges, because it is not constructed for this purpose. Our second basic type of flexible coupling is the grid type. Again, this coupling does not utilize very many parts for its operation. There are 2 hubs, one mounted on each shaft. The hubs are joined by these steel spring grids, 1 ton for each 180 degrees of the coupling hub. The grids are mounted in the grooves of the 2 hubs to transmit power from one to the other. The 2 bell halves are then slipped over the coupling hubs and grid and bolted together. The bells serve mainly to hold the grid in place and to contain the grease that is used as lubricant. They are not really part of the drive train, as the bells in the gear coupling were. The bells then have a grease plug for lubrication purposes and grease seals to prevent leakage. And that's all there is to this basic type of grid coupling. As we mentioned earlier in this course, the grid coupling is quite commonly used. It will compensate for minor misalignment and for some axial movement of the shaft. And the steel grid will also absorb shock, such as power surges. This provides a cushioning effect that spreads out the peak or heaviest loads and reduces stress in the coupled machines. Our third basic type of flexible coupling is the disc coupling. The model we're showing you now is a very common type now in use. The name disc is derived from this disc in between the coupling hubs. By taking a closer look, you'll see that the disc is made up of a number of thin, flexible metal plates that are laminated together. This type of construction gives the disc the required strength, yet allows it to retain its resiliency. As you can see, the disc coupling is not very difficult to understand. There are 2 coupling hubs. The hubs are then joined to and by the disc which is secured by alternate bolts from each hub. To give you a better idea, let's take a closer look. These bolts fasten the disc to the hub on your left, while these bolts hold the disc to the hub on your right. In short, all of the bolts are fastened to the disc in the center, but every other bolt from the disc is fastened to opposite hubs. There are also bevel washers on the bolts on each side of the disc. This ensures added flexibility in the operation. As you can see, the workman is now flexing the hubs to show that the disc arrangement allows the coupling to flex and give. He now flexes it in the other direction to show the other extreme. Because of this design, this coupling will compensate for slight misalignment and some axial movement, and some models will cushion shock loads due to power surges. Two more advantages are that no lubrication is required, and all components are visible. This makes the disc coupling a very desirable type in many applications. Those are the three basic types of couplings that we will show you in the flexible class. Naturally, there are other types of flexible couplings, and even variations of the ones we have shown you. However, once you become familiar with the basic types we've shown you, you'll find that you can apply your knowledge to other couplings you come in contact with. We'll show you how to install and remove these flexible couplings after you complete exercise number 5 in your workbook. This segment of our course deals with the general methods and procedures used to install and remove flexible couplings. We'll cover the basic procedure for the installation of a gear coupling, then explain any differences in installation procedures for the grid and disc couplings. First, assemble the required tools, equipment, and supplies for the job. Then put on the proper protective equipment as required by your plant. The initial procedure of checking the sizes of the hub bores against shaft sizes is the same as that we showed you earlier for the rigid flange coupling. Obtain the appropriate keys. Complete all of the measurements, and be sure that all of your fits and clearances meet manufacturer's specifications. Again, the installation of the hubs for the gear, grid, and disc couplings is identical to that you learned earlier for the rigid flange coupling. Once you have completed your measurements, slide both of the coupling bells onto the shafts, like this. Try to position them back out of the way so they will not interfere with your installation of the hubs on the shafts. You will also need to provide some type of protection for the grease seals on the bells. If you don't, the rubber seals may melt or become damaged due to the heat as you install the heated coupling hubs on the shafts. You may even wish to remove the grease seals from the bells or isolate them from the hub area by one method or another. This will vary according to your particular situation. Once this is done, you would heat the coupling hubs to the required temperature and install them on the shaft as you did the rigid flange coupling earlier. After the hubs are installed and have cooled, tighten the set screws on the keys. As with the other couplings, this is the point at which you must align the two pieces of equipment and maintain previous recorded distance between hub faces. Once the alignment is complete, you are ready to complete the installation of the coupling. To do so, install the grease seals in the coupling bells, if they were removed. Then slide the bells over the coupling hubs, ensuring that the gear teeth on the inside of the bells are meshed properly with those on the outside of the hubs. Then align the bolt holes in the bells and bolt them securely together with the appropriate gasket between their faces. Your installation complete, your final step would be to grease the coupling with the proper lubricant according to the manufacturer's specifications. Removal of the gear coupling is quite simple. Remove the bolts from the bells and slide them back out of the way. Measure the distance between the coupling hub faces and record your findings. Remove the locking devices, such as this set screw that holds the key in position. All that remains is to pull the coupling hubs off the shafts with coupling puller, or, in case of an interference fit, to heat the hubs and pull them off. That's basically all there is to the installation and removal of a gear coupling. The installation procedure for a flexible grid coupling is practically identical to that of the gear coupling. Don't forget to slide the bells onto the shafts and move them back out of the way. Protect the grease seals from the heat of installation. Once the hubs are correctly installed, align the grooves in the hubs like this. You can then place the grids in the grooves and tap them into place with a soft hammer. Do not use a hard hammer during installation, or you could damage the grids. Once the first half of the grid is installed, complete the second half in the same way until both grids are mounted properly in the coupling hubs. You would then slide the coupling bells into place with the grease seals in place. Bolt the bells together with an appropriate gasket between the bells. The only difference in removal of a grid coupling from a shaft is that you must unbolt and slide the bells back. Then remove both of the grid members from the hubs. The remainder of the coupling removal is identical to the gear coupling. The disc coupling is also installed along the same general lines as the gear and the grid coupling. First of all, it won't be necessary to slide the bells over the shafts before installing the coupling hubs, because there are no bells on a disc coupling. Once the hubs are properly installed on the shafts, your first step will be to turn the hubs so that these buttons will be directly opposite each other. Now measure the gap between the buttons. The thickness of the gap must equal the thickness of the disc that will be installed between the buttons. After you have taken the measurement and adjusted the gap, turn one of the hubs so that the buttons on each hub will fit into alternate holes in the disc. Install the disc between the buttons and bevel washers and secure with the appropriate bolts and self-locking nuts. That's all there is to the installation process. Remember that the flexible disc coupling does not require any type of lubrication. The removal of a disc coupling is very easy. Just remove the bolts and nuts from the disc and hubs, and slide the disc out of the coupling. From that point on, the procedure for removing the hubs is the same as the gear or grid coupling. Remember, the methods and procedures we have shown you for installation and removal of these basic types of flexible couplings are to be regarded only as guides. There will always be some variation to the procedure, either because of the coupling construction or the conditions under which you're installing the coupling. Your plant may also have specific requirements for coupling installation and removal that must be followed at all times. If this is so, your instructor will tell you about them. If you have a question about a coupling, check the manufacturer's manual or ask your supervisor. He will be glad to help. We have some questions for you on the installation and removal of flexible couplings. You'll find them in exercise number 6 in your workbook.